So, day 2 of lesson 5.5, still talking about composition functions. Yesterday we were used to seeing this, right? We were used to seeing that being written. What we're going to talk about is what this means. Okay, f of g. Now that doesn't mean multiplying necessarily. Okay, f of g, I want you to understand, it means the same thing as what we were talking about yesterday. F of g of x. Okay, so if you ever see this notation here, understand it means the same thing as what we looked at yesterday. Okay, now if I flipped this, if I said g of f, what's that the same as? G of f of x. Yep, it's the same thing as what we said yesterday. Okay, so like I said, this notation is the same exact thing as what we said here yesterday, just different notation. What I want to do is I want to look at this example. It's not in your notes yet, so if you want to write it off to the side, you can. So f of x equals the square root of x plus 7, and g of x equals 2x minus 5. Okay. So what it wants us to find is this f of g of x here. I just told you, how can we rewrite that into terms we're used to? How can this be rewritten? We can go f of g of x. We can rewrite it to what we're used to. Okay, so order of operations, we normally work with what's on the inside first, yes? So do I know what g of x is? What's g of x? Yep, so I'm going to take that 2x minus 5, and I'm going to plug that in for g of x. So now I have f of 2x minus 5. Okay, so now what I want to do is I want to find f of 2x minus 5. What am I going to do with this 2x minus 5? If it's in the f function, so instead of f of x, I have f of 2x minus 5. We're going to put it in for the x in that f function. Okay, so what this is going to turn into is it's going to turn into the square root of, now instead of that x, this is what's replacing it. So 2x minus 5 plus 7. Okay, so all that happened was this, what I had here, replaced the x that it started with. Okay? So now we just have to simplify this. Looking on the inside there, can I do anything? Yes. I can combine like terms, right? Does 2x have a like term? Nope. What about negative 5 plus 7? Positive 2. And then once you're simplified, you are done. So up here, it wants us to find f of g of x. Remember, what does this mean the same thing as? How can we rewrite that to what we're used to? Yep. Yep. What I want you to understand, these mean the same exact thing. That's why we can do that. Okay. This says f of g of x. This says f of g of x. Okay. So first thing we do inside, do I know what g of x is? What is it? Yep. So now I'm looking for f of 4 minus x. Now that I have it rewritten, because I substituted my g of x in for g of x, what do I do with that 4 minus x? Into which function? Yep. Which x? It's going to be both of them. Yep. So when I rewrite this, we go 4 minus x squared. So whenever there's an x, it replaces it. Okay, and then plus, what do I put next? 4 minus x. And then I still have plus 2. So again, to rephrase this, I was plugging in 4 minus x into my f function because f is here. Wherever there was an x, I replaced that x with what we're plugging in. Okay? So now it's just a matter of simplifying. What does this mean? We're going to have to. How can I rewrite this? Yep, 4 minus x. 4 minus x. And then I'm just going to rewrite what I have left for now. Now I need to do what? I could. Let's focus on this first. What can I do with this? Yep, let's FOIL that out. 4 times 4 is 16. 4 times negative x. Negative 4x. Negative x times 4. Negative 4x. Negative x times negative x. Positive x squared. Yep. And now I'm going to just write what I have left. I have plus 4 minus x plus 2. What's usually the last thing that you're going to do? Yep. Last thing in simplifying is combining like terms. What do I need to do, though, when I'm combining like terms? Yep. Start at the highest degree when I write it in standard form. So my highest degree is, yep, x squared. So I have x squared. Now I'm going to combine like terms. What's negative 4x minus 4x? Negative 8x minus x. Negative 9x. And then I have 16 plus 4. 20 plus 2. 22. And then once you have it simplified, you are done. That is your new composite function. So on this one, this is your example 5a. It wants you to find f of g. Well, let's rewrite that to what we're used to. How can I rewrite that? Yep, f of g of x. These say the same thing. Yep. Okay, remember, look on the inside. Do I know what g of x is? Yep, what is g of x? Yep, so I now have f of x plus 1. What do I do with that f of x plus 1? What did you say? Yep, we're going to plug this x plus 1 into our f function. So this turns into x plus 1. Right, it's x plus 1 to the third, but you're on the simplifying step now. What does this mean? It's itself 3 times. So this turns into x plus 1 times x plus 1 times x plus 1. Okay. How do we simplify? We're going to distribute. Can we distribute 3 things at once? No, we're just going to do these first 2 first. Okay, forget about the third one for now. What's x times x? X squared. What's x times 1? 1x. What's 1 times x? 1x. And then 1 times 1? 2. And then I still have that x plus 1. Yep, so we're going to distribute again. Is there a way I can condense this first part? Can I condense this? What I mean by that, simplify? Yep, we can combine like terms here. So this turns into x squared plus 2x plus 2 times x plus 1. Now what do I need to do here? Distribute again. Yep, so x squared times x cubed. X squared times 1. Remember, anything times 1 is itself, right? Next I have 2x times x. 2x squared. And then 2x times 1. 2x. Last one here, I have 2 times x. 2x. 2 times 1. 2. Yep, now the last thing we got to do is combine like terms. What do I do? What do I need to do first? Highest degree, which is? Yep, x cubed. So we have x cubed. And then what's x squared plus 2x squared? 3x squared. 2x plus 2x? 4x. And then plus 2. It was long, but we made it. Again, when you see, this is your example 5b, if you see something like this, we want to rewrite that into what we're used to. How can I rewrite that? F of g of x. Yep. So now we can solve. Do I know what this inside is? What is it? What do I do? Yep, so I substitute f of 4x plus 11. What do I do from here? I'm going to plug it in where?
It's an x in the side that whatever those things.
In the f function, right? I'm going to substitute 4x plus 11 in for x. So this turns into 3 times the square root of 2. What do I do next?
Plus 4, or times 4.
Yep.
X plus 11.
Good. Yep. So again, this just replaced this x value. Now we just simplify. How do I simplify this farther?
Do the parentheses first.
Yep. So I'm going to keep what I have on the outside. What do you mean by parentheses here?
The parentheses, like 4x plus 11.
Yep. Can I simplify 4x plus 11? Like, I can't combine them, right? So what can I do with that 2 out in front? Distribute here. 2 times 4x. 8x. 2 times 11. 22. I'm going to ask you this. Can I take this 3 and distribute it in?
No.
Why not?
It's on the outside of the...
It's on the outside of the radical. Yep, if this was parentheses, then without the radical, then can I do that?
Yeah.
Yes, but that radical kind of closes it off, so this is actually as far as we can go.